So we're doing applications, and it says the amount of instant porridge oats, I don't know what those have to be together, in packets packed by a particular machine is normally distributed with a mean of mu grams and a standard deviation of 6 grams. The advertised weight of the packet is 500 grams. Calculate the proportion of packets that will be underweight, less than 500 grams, when mu is 500 grams. I'll go like this, and I'll say, okay, X is normally distributed, and I know it's like this. All right? And I'm going to go, why do I have 505 here? Did it say something about 505? Oh, it says here, sorry. I can put 505 in there then. I'm going to put that, and then for my problem I'll go X is normally distributed, because this is just for A, 505 and 6 squared. Okay, and so I go X, or the probability that X is less than 500 is equal to, and then I'm going to grab my calculator. And go second dister, normal CDF. And my lower is whatever's there, negative something. And my upper is 500. And this is 505. And this is 6. Is everybody cool with that? And I get this value. So really straightforward, that one. 4 decimal places we always use when we're doing these. Okay. Okay. The next one says calculate the value of mu required to ensure that only 1% of packets is underweight. So what I would be looking for on a test is something like this, because I don't know what that is yet, and this is 0.01. Does everybody agree that that's 1%? And when I have that area, what do I have to use on my calculator? Well, second dister inverse normal. But when I get to inverse normal, it requires that I have the mean, and I don't have the mean. So what happens when you don't have the mean? Do Z. Yeah? Okay, so we'll put that. Requires Z equals X minus mu over sigma, since we are finding mean. And you don't have to write that on the test. I'm just writing it for your notes. Okay, so we're going to use the Z score of, I don't want to look at where I'm looking at here. Inverse normal. I know the area, 0.01. I'm going to use the 0 and the 1 because I'm using the Z, and I'm on the left. Agreed? Left tail. So there it is. That's the Z score. So that's this thing on there. If this is 0, this is negative 2.3263. And now I use my formula, negative 2.3263, or you can use what's in your calculator. Everybody see where I got everything? Okay, so that times 6 is that. I just took that over there and that over there, added it. Oops. You okay? Okay, so when you're missing something, that you need in your calculator, that's the hint to use the z-score. Okay, now the C, to me, is the real application question. So the C says, as a check on the setting of the machine, a random sample of 5 boxes, I don't even know what box it's in packets, I don't know the difference between that, it's a bad, poorly worded, I think, is chosen, and the setting is changed if more than one of them is underweight. Calculate the probability that the setting of the machine is changed when mu equals 505 grams. Okay. So now I have this thing where I have 5 boxes and I'm testing each one, and if one of them's underweight, blah, blah, blah. Is that continuous still? No. Now that's binomial. Why is it binomial? Say it again? Yeah, it's underweight or overweight. That's good. And it's 1, 2, 3, 4, 5 I'm talking about. I'm not talking about 9.95, blah, blah, blah. Right? Okay. So here we go. Let's let it be y. You want to do that instead? Because I already used x. So y is binomial. If you used an x, it wouldn't be bad. And there's 5 boxes. Now, what's the p, though? Because remember the binomial setup is x is binomial distributed, and then it's the n, how many trials, and the p, probability of success, or in this case, probability that one is underweight. Do we have that? We found it up here. Right? So that's the probability that x is under 500, and that's what we're looking for. One of them is underweight. Yeah? So there we go. That kind of happens frequently, where they have you do a question, and then they use that probability underneath. Okay, so that's how it's distributed. Now, we want the probability that y is more than 1 is underweight. So y is this underweight? Underweight is greater than 1. Right, because underweight is the thing. So we want to see if y is a bit more underweight, more of them are underweight. Yeah. But when I do binom, do you remember this? When you do binomial, this binom CDF, it just gives you this little thing, and it doesn't have an upper value and a lower value. It only gives you the lower. Okay, so this is really 1 minus the probability that y is less than or equal to 1. Is that okay? Because this is greater than 1, so it's 2, 3, 4, 5, and this is 1 or 0. All right, so I'm going to type it in. It's 5 trials, and there's the probability that I already figured out before. And that's 1, that value. And so probably I would write, because that was my 505 grams from you, I would write something. No, therefore, that's the probability that more than 1 is underweight. You okay?